Hey guys, we're doing 34-2 notes today. It should look like this. Again, if you can print it, great. If you can't, it's really important that you take notes on paper so you have something to look back at, especially to show your work with the formulas and everything after that. Before we get to this, I'm going to show you a video that kind of explains volume a little bit. So it's a 12-minute video. We're only going to watch a couple minutes of it. So go ahead and just watch. No note taking right now.
So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there are different perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume, while the volume itself is the amount of 3D space occupied by the ice inside the box.
So again, this two-dimensional net, that's the surface area, which we studied yesterday. The outside surfaces added up, and what's inside, as he said, the ice, the amount inside is volume. Okay, and then we'll go to 5.5.
A lot of 3D shapes can be formed by taking a 2D shape and then extending it along the third dimension. For example, if you start with a rectangle and then extend it along the third dimension, you get a 3D shape called a rectangular prism. If you start with a triangle and then extend it along the third dimension, you get a 3D shape called a triangular prism. And if you start with a circle and extend it along the third dimension, you get a 3D shape called a cylinder. From the others, you might have thought that it should be called a circular prism. But technically, prisms are shapes that are formed by extending a polygon. And since a circle is not a polygon, the resulting shape is not called a prism. Okay, so the good news is that there's a general formula for calculating the volume of these types of 3D shapes. All you have to do is find the area of the original 2D shape that got extended, and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle, and its dimensions are 4 centimeters by 3 centimeters. So
You don't need to write any of this down, just watch the video. No notes yet.
to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40, so the area of the triangle is 40 inches squared. Now all we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches, and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters. So if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.
I don't want you guys to use 3.14. I'd like you to use the pi button when you do it. We'll talk about it in the notes.
12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle is extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of this cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape, and then you multiply it by the length that it was extended, and that gives you the volume. And it works for any 2D shape. It works for trapezoids, or pentagons, or diamonds, or stars.
Alright, so I really like that video because it's exactly what I wanted to show you for volume. To find the volume, you do what it says in the video. Like here, you take the volume of this triangle, multiply it by how far it was extended. Find the area of this base, multiply. Find the area of this base. So the formula, which you can write down in your notes, is I use capital B, H. And it's really important you write down what these letters stand for, like we did yesterday when we wrote this down. Sorry, I didn't leave you a ton of room. Capital B, just like yesterday, is not just one of the numbers at the bottom. It's the area of that base. So the area of the triangle, the area of the circle. So make yourself a note that B stands for area of the base. H is the distance it was extended, the height of the whole prism. There we go. I'll put it right there. Same as yesterday, the distance between the two bases, how far one base was extended through to the other base. Really, really important you write the formula and what these letters stand for. So what is volume? In the video it was that ice in the middle, but it's not always going to be ice. It's whatever fits on the inside of the object. So I would have you write the amount of space on the inside of a figure. Pause the video at any time to slow it down. All right, let's do some practice problems. First question, always show your work, assume all units are in centimeters. So instead of labeling them all centimeters, I just want you to assume that they're all centimeters. Find the volume of the blank. What is this? It's a prism. What's the shape of the base? It's a triangle. Not because it's on the bottom, it's not always going to be on the bottom, but because there's a triangle extended all the way through to another triangle, and everything else is a rectangle. So it's called a triangular prism. Always start with the formula and some nice blanks. So we have to find, two things, area of the base and the height. So off to the side, I'm going to put capital B, just like yesterday. What shape is the base? It's a triangle. So you need to write capital B, so it's labeled, and what B stands for, the area of the base, triangular base in this case. 1/2 base times height. Take a look at your triangle. What is the base and the height of the triangle? 8 is the base, 12 is the height. Multiply that out. I think you could probably do it in your head. 1/2 of 12 is 6, so 6 times 8 is 48. You've just found capital B, and you do have to show work for that, even if it's pretty basic. So capital B is 48. The height, remember that's how far it's extended from one triangle base to the other, and that's going to be 14. Multiply those together. 672 centimeters cubed. Volume will always be cubed. Okay, watch it again if you need to. Let's try the second one. Find the volume of the, what's this called? Looks like a circular prism, but we call it a cylinder. Don't call it a circular prism because it's not made of straight sides. Write your formula. And then neatly show some work off to the side for capital B. So, what's capital B? It's the area of the circular base. Area of a circle is pi r squared. My radius is 12. I think many of you know 12 squared is 144. And we're just going to leave 144 pi for right now. Let's not worry about a decimal yet. We'll do that at the very end. Fill in capital B is 144 pi. What's the height? Remember, the height is how far this circular base was extended to the other circular base. 32. Now you can type 144 times pi times 32. Big number, 14,476.46 centimeters cubed. I would always round to 2 decimal places. Hopefully you're starting to notice a pattern. Find the area of the base, multiply by how long it was extended, similar to the video. Number 3. Find the volume of the blank. What is this called? This is a 5-sided figure called a pentagon. And there's a pentagon in the back. You just can't see it. So it's a pentagonal prism. What does this mean? Assume the base is regular. So assume this pentagon is regular. What's regular mean? All sides and angles are congruent. So this pentagon, this side is 4, 4, 4, 4, and 4. That's what that means. You'll need to know that. Okay, what's the formula for volume of a prism? Area of the base times the height of the prism. Off to the side, neatly showing our work for the area of the base. So that's a pentagon. What's the formula for area of a pentagon base? 1/2 AP, 1/2 apothem perimeter. If you're having trouble remembering these area formulas, you should have a sheet from last unit with all of your areas. Area of a triangle base, a rectangular base, a pentagonal base, a trapezoidal base, all kinds of bases you can find the area of. My apothem is 3. What's my perimeter? Well, here's my pentagon. I mentioned it's going to be 4, 4, 4, 4, and 4. So 4 times 5 is 20. 1/2 apothem perimeter. Multiply that out and you get 30. 30 gets filled in for a capital B, area of the base. Height, how far is it from one pentagon to the other pentagon? 7. Multiply that out, you don't even need a calculator. 3 times 7 is 21 with a 0. Centimeters cubed. All right, the last question is find the surface area of figure 3. So still working with the same figure. Today we're doing volume. We did surface area yesterday. So look back at your notes. What's the surface area formula? 2b plus ph. And what did these letters stand for? B stood for area of the base. Is that what this B stands for? Yes, area of the pentagon base. Yesterday it stood for area of the pentagon base. H stands for height, the distance it was extended. That's exactly what this H stood for yesterday also. And P stood for perimeter of the base. So we've already found capital B and H. Capital B was over here. You don't have to show the work again because you already did it. The area of this pentagonal base is 30. Let's fill in height because we already have that. The height of the prism is 7. And then perimeter of the base. So go ahead and look at your pentagon. What is the perimeter of this? Well, 4, 4, 4, 4, and 4 is 20. Grab a calculator, multiply that out to get your surface area. Don't forget the units for surface area is centimeters squared. There you go. You can start your homework.